Greetings! Today we have another generous donation to the channel. This is a soundboard out of a second generation Bally solid state machine, pinball machine that is. It was donated with the comment that came out of a storage box. It's kind of dirty. So this was stored for a long time. Working condition is completely unknown, but just looking at it, giving you an overview. The second generation of Bally pinballs used the 6803 processor on the main CPU board. So it's interesting to note that the soundboard is a 6809, which is obviously more powerful than a 6803. So this must sound pretty good. We got RAM, we got an EEPROM that says Strange Science on it, and a 6821 PIA, other assorted stuff. So before I clean up boards like this, I usually do some basic tests, because I don't want to waste my time cleaning something that is not repairable. And if I forgot to mention, this is called a turbo cheap squeak for pinball, or TCS for pinball for short. There was never a shortage of coming up with cool names, but well, let's see what ails this one. So I'm not going to build a test harness for this, because all it needs is a 14 volts unregulated DC supply. But the interesting thing to note is, see all these ground connections I've made? This board has 3 separate ground connections that are not connected on the board at all. It's a good design practice to keep grounds separate. This has an analog ground, a digital ground, and a supply voltage return, which is also a ground. And what the design guidelines say, or what the textbooks say, is basically if you have different sections, then you should not tie them together at several points inside your system, but rather only at one point. And that's the approach they followed here, because we got 3 grounds that are not connected on the board. They are connected on the main regulator board, and in theory that'll work fine because it'll keep your grounds clean. Problem is, especially in a pinball machine of this age, connectors, contacts get dirty and basically raise or play havoc with the different ground levels, which plays havoc with the proper operation of something like this. So if you have a system that has grounds that are only connected together in one place, where the boards depend on some other place for all the grounds to be tied together, make sure that all of the ground connections are clean, have an extremely low resistance, and if not, if you find one that doesn't, make sure you fix those ground connections before attempting to fix anything else. Well, in this case we don't have a problem, because I ran the ground from my bench supply into all 3 sources over here. We have power in here, and what's supposed to happen is, when this is powered up, this green LED is supposed to blink. It's a diagnostic LED that tells us if there's anything wrong or not, but that would be our sign of life. Now I'm only using 12 volts, and I got it current limited, just in case. Not that it really matters, because I'm sure this board was powered up before, probably inside the machine, and but probably deemed inoperable. But let's see what happens. So I'm turning on the power supply. And we got 3 blinks. Now that was interesting. That means it should be working. So what happens if I press the test button? Nothing happens, but it's probably trying to generate sound. So let's power cycle it again. This time we got 2 blinks. So something is not too happy in here. 1, 2. We're only getting 2 blinks. And it's only consuming like 180 milliamps. So something, I mean, the processor obviously woke up, but it's telling us that something isn't working here. So let's have a closer look at the board. Well, let's check voltage here. And we have ground and 5-volt test points. And get this thing to stay and show up, which it doesn't want to do. Okay. So from ground to 5 volts, we get 1.3 volts. So how did this manage to do anything? So if we look at the regulator, let's see, I need some light so I don't short things. But keeping 1 probe on ground, checking the output of the regulator, it's being weird. Very strange. The input to the regulator now is 9.5 volts. We're pumping 12 volts into this, so because of the crappy wires, alligator clips, it's losing some voltage, but it's 5-volt regulator. Anything above 7.5 should make it work. But when I touch the output pin, whereas before it told me that the 5-volt rail is at 1.26. So things are kind of strange, but obviously the regulator has a problem. And I just noticed something that some of you may have noticed, and that is, here's the regulator. And if you look closely, there's a chunk missing out of the case here. Right here, that I can poke with my pointer. It's 7805. And it obviously had some thermal problems and blew a chunk off, and that's probably why it's not working too well. So the first order of business is, let's replace this regulator and see what happens then. And here's what came out of the board. These were separated. I didn't do this. And so it looks like the substrate's still here, but because of excessive heat, this broke off. But the excessive heat was generated by the chip itself, so it probably self-destructed. The funniest thing was they used a thermal pad and thermal paste. And in this case, double is better does not apply. You use either or, preferably the paste. Thermal pads are a convenience for manufacturing, but you want to use paste because that is more effective. So I put a new one in, and let's see how that behaves. So the new guy's in. Watch this LED over here. I'm going to turn on power. We get 3 flashes, 3 blinks, which is I guess what we should be getting. Let's try it a couple more times. Consistent. Yeah, and for completeness, let's of course measure the actual 5-volt rail run now. The old Radio Shack meter says 5.01 volts. So there you have it. The digital part at least seems to work. So now what we got to do is drag out a speaker and see if we can make it emit any cheap squeaks in turbo fashion. I gave the board a bath. So it's clean for its final test. Nothing fancy, toothbrush, soap and water, and then a few minutes of hair dryer to get all the water out. I didn't see any need for using alcohol, and so here we have it. Let's see if it still works. Now I read up on it, and the LED is supposed to blink 3 times, and that means whatever it can test, it will test, such as the memory, checksum on the ROM, internal registers on the PIA. So if it doesn't blink 3 times, you can look it up, and whatever blink it stops on, it'll tell you what it's detecting that doesn't work. So let's do this again. So now all that remains is I heard a click out of the speaker over here. If we hit the test button, it should make some sort of noise. And it does. A poor imitation of a bell. I mean, they're using a D2A. They have a ROM over here. I'm not sure if this is just a plain sample or if they're algorithmically generating the wave. But it's not that big of a ROM, so probably. And there's more sounds in here. In order to test all of the sounds, this would either have to go into a machine, or I'd have to set up like an Arduino or something to generate the signals on the digital input over here. But I think the fact that it makes this beautiful bell sound indicates that it's mostly functional, and if it doesn't want to communicate with the host CPU, it's simply 1 or 2 of the chips that buffer the signal coming from here. So we're going to stop there and call this a success. Thanks for watching. Please like, subscribe, and leave a comment, and we'll see you next time.